Welcome to Talkin Tires, the podcast that delves deep into the world of tires. Join us as we explore everything from the science behind the manufacturing to the latest innovations in tire recycling. Our aim is to provide you with a comprehensive understanding of tires, including how they work, how to maintain them, and how to dispose of them responsibly. Whether you're a seasoned mechanic, curious car enthusiast, or an avid recycler, Talkin Tires is the perfect podcast for anyone who wants to learn about the essential component of the modern vehicle and heavy equipment. So buckle up and join us for an informative and engaging journey into the world of tires. All right, welcome to another episode of Talkin Tires. I'm your host, Craig Hunter, president of Tire Reclaim, and I'm here with Red Clark of Asphalt Plus. And we're seeing a real buzz around the show today. Thank you for being here. About RMA, rubber modified asphalt, and other asphalt processes that involves crumb rubber. So we wanted to chat with Red a little bit about what he's got going on, what's coming in the future, but more importantly, about the man. Red, welcome.
Thank you.
I'm glad you're here. Yeah, so how long have you been in the RMA and tire recycling world?
I've been in the tire recycling world for about 20 years. I have been in the larger recycling world for about 45 years.
Okay, tell me a little bit about that. How did you get your start in recycling?
Well, I made a wrong turn somewhere. That's all I can tell you.
I hear that a lot.
Yeah. I started out, believe it or not, as a university professor teaching in environmental science and engineering areas. I left early in that career to go into the private sector just because it's tough to feed your family on what they pay teachers. So I transferred over into consulting engineering, then into a fairly senior state environmental management position, and then into the private sector. And my first company was a recycling company. Grew that into a really substantial national firm. Sold that out to Waste Management, then took over another struggling company that was trying to get rubber into asphalt. And we've taken that up now to the point where we're operational internationally in Asia, Europe, Central America, and in North America as well.
Yeah, when we first met and I reached out to you because of Idaho and our growing need for outlets for tires. So we at Tire Reclaim, we've set up there, it's kind of our niche. A little bit of Eastern Oregon, a little bit of Wyoming, but mainstay is Idaho and what to do with Idaho tires. So I started looking into asphalt and different things, and we are not doing anything. So I reached out to you. We had a great call with our diversion specialist, Tara, myself, and you, and some of the things that you went over were really kind of earth-shaking for me with the amount of miles that you've already got under your belt. And that was something I said, so we're talking thousands of miles, and I think you said tens of thousands of miles, which is going to produce data, right? So that we can approach our state and start talking about utilizing rubber in the roads. Where did a lot of that success come from with that many miles on the ground? Is it the process? Is it the days and nights of you putting in the long hours and convincing folks? Where would you put some of that success?
Well, the answer is that, what is it? Success is 10% invention and 90% perspiration, and that's definitely the case here. The only way that you are going to get rubber products into asphalt pavements is by putting in an enormous amount of effort and investment and time to show people that it can be done, number one, and number two, the quality can be controlled, and number three, to show them that the economic benefits of what you're doing for all of the participants in the transaction, the economic benefits make it worthwhile. Rubber, people have been trying to get rubber into asphalt as a commercial reality for more than 50 years. And it has consistently been a failure because we didn't fully understand the rules of the paving industry, and because we didn't pay attention to the economic rules that we had to comply with. A lot of people have a tendency to fall in love with their technology. The market is looking for results. And so if there's a success to be identified here, it is simply recognizing, learning, and understanding what the market is asking for, and then finding ways to configure rubber so that we'll deliver on the needs of the industry. As I said before, that required an awful lot of work. the paving industry is really interesting. The paving industry does not have the ability to predict that if you make a change to a road design, they're not able to easily predict what's going to happen 10 or 20 or 30 years down the road. If you make an improvement to a pavement and it works, it's a wonderful thing, but typically it will save $1 or $2 or $3 per mixed ton. That would be a typical advancement in the paving field. But if you screw that pavement up, the cost of replacing the pavement that you broke is $250 or $300 per ton. So there's an enormous loss and a relatively small gain, which makes it a very dangerous business, and people have to be absolutely convinced that it is going to work. And the only way to convince them is to start putting pavement on the ground, and put more pavement on the ground, and be patient, wait for the industry and the market to kind of catch up to what you're doing. So we put our first pavement on the ground using what's called dry process rubberized asphalt around 2002, so just short of 25 years ago. And it has taken 22 years or so for the industry to really understand and say, okay, we accept that it works, let's go. And at that point, we start to see hockey stick-like growth, which is what we're seeing right now. And we start to see more and more regulatory agencies or departments of transportation grab onto the technology, acknowledge that it works, and turn it loose. So our success has been a long, expensive level of effort with a lot of people putting their shoulder to the wheel.
Yeah, I had met with Levon Detweiler of Intech quite a few years ago, and he says, well, all I know is that, I think he said he spoke at a conference, maybe one of these, and he went up in front of everyone. He says, all I know is that we keep talking about trials and we keep talking about testing. He's like, when are we going to start putting this stuff down? When are we going to actually, complete the circle and get this done? And what it sounds like is you're starting to see that happen. After all these years, you have the data to back it up. So you see the hockey stick growth. What's been some of the pushback? What has it been? The contractors driving that? Is it the naysayers? Is it somebody?
Everybody.
Everybody.
So you go down the list of the people that are in a position to say no. The first gatekeeper is the road owner, which will be not only the state DOT, but it could be the county road commission. It could be the public works department in a city. All of those people have the ability to say, I don't want to do this. Okay, and they each have to be convinced. The second gatekeeper are the people that run the mix plants. When we tried to push what is called wet process rubber, which is rubber, tire rubber, put into binder, asphalt liquid, cooked, and then put into the mix, it creates a sticky, smoky, difficult to handle mix, and it gums up plants. So the mix producers lose an enormous amount of money if you jam up their plants. So there's risk there for them too, and they want to be absolutely convinced that when they put this material in, they know that the plant's going to run normally and that they're going to produce a good quality mix. And the only way you can convince either of those gatekeepers is experience, time, data. So the postage stamp trials that we started out with, that might be a few hundred tons, have now advanced to the point where our largest projects are more like 200,000 tons. And if you think about the levels of modification that we typically see, it's a half a tire per ton of asphalt mix. So in one project, if you have 200,000 tons of mix, you're using 100,000 scrap tires in a single project. And when that happens, and those projects are happening now, you are no longer looking at agencies that are saying, we're not sure we trust it. You're looking at agencies that are saying, go. And you are looking at now hundreds of contractors that have tried this, run it through their plants, have said, go. And
we're talking about the dry process now.
Yes.
Yes.
Wet
you want
process,
to go into that a little bit, the comparison of the two? And,
So wet process involves adding rubber to a heated liquid binder, cooking it for typically hours or as much as a day, causing the rubber to absorb some of the lighter ends of the binder, swell up, and then that blended mix is agitated to keep the rubber suspended because it will settle out if it's left alone. That mix is shipped off to an asphalt mix plant where it's added to aggregate and turned into an asphalt mix. Wet process is sticky, okay, and it attempts to replace another rubber process that the plants are using right now called polymer modification. They take virgin synthetic rubber and they put it into the asphalt binder in significantly smaller percentages. Polymer modification is the dominant form of asphalt modification in the industry right now, and it's cheaper than wet process rubber. All of the contractors that are bidding on jobs have to be the low bidder to win the job. And if you are using a process that's more expensive than somebody else, you run the risk of losing the job. So the wet process rubber has been tried, and the only place that it's used commonly is where the government forces the contractors to use it. They don't give them a choice. If the contractors are given a choice, they will not use wet process rubber. Dry process rubber was invented in response to the shortcomings of the wet process. In dry process rubber, a very fine crumb rubber is chemically re-engineered, and it is blown into the mixing process while the asphalt binder and aggregate are being mixed together at relatively high temperatures. So the rubber distributes itself through the mix, and then it goes into a truck, out to the paver, and gets laid down and compacted on the road. When you put rubber into a pavement, the pavement is more resistant to cracking, and it's more resistant to rutting, which is that deformation in the pavement that you see when you drive up to a stoplight and you walk across the street there, and it's like a roller coaster with the pavement going up and down. Yeah. That's rutting, okay? And you want to try to, they can be very dangerous, both on stoplights, but they're also very dangerous on interstate highways when all of a sudden you can't freely turn your wheel because the depression is holding your wheel on a particular path.
I felt it. I know exactly what you're describing.
Right. So what rubber does is that it stiffens the pavement and makes it more resistant to rutting, but the rubber also interferes with cracks that work their way through the mix. And if you look at samples of mix that are being cracked in a lab, you can see that the more rubber you put in, the more crack resistant they become. So cracking and rutting are the two primary forms of asphalt pavement failure. The road owners would like more durable roads. They would like them cheaper. Dry process rubber is cheaper than wet process rubber. It's cheaper than polymers. Today, in part because of the Gulf War, it's about half the price of a polymer modified asphalt, which is a huge advantage. In the asphalt pavement industry, if you can save them $1 a ton, they're very interested in picking up that technology. Typically, compared to polymers, dry process rubber will save them $3 to $5 per mixed ton. So it's a huge savings, and it's very interesting.
I'm thinking about the PowerPoint you had shared with me early on, and it showed photos, and so we're talking a plant that's an additive piece of equipment. The bag system feeds right into the mix station, right? So that's literally getting tipped into the asphalt mix,
into the feeder. No, it's being into a feeder, which will then carefully measure the amount of rubber that is being put into the plant to match the amount of mix that is going through the plant.
Gotcha.
Because these plants will run slow speeds, medium speeds, very fast speeds. So you have to have the ability to adjust the rate at which the rubber is going into the plant in order to make sure that you're getting the right change in your mix.
And this is the process you've seen the most success with, you're seeing the most miles getting down, is the dry process.
Dry process is dominating when you look at growth of rubberized asphalt in the US and now in Europe, dry process rubber is the dominant force.
It's very exciting. I think
it is.
People have been waiting a long time for this to start coming about. I think the wet process gave some bad tastes in some contractors' mouth, and someone told me a story. I won't have any of the details right, but they basically didn't get the temperatures right. They screwed up a bunch of miles of highway, and now the half a dozen contractors said, "Not me." So it really kind of tainted, because they didn't have it right, they tainted the whole contractor base. So then it's harder to get more people to sign on to something like that.
That's right. So there are lots of entrepreneurs now that are coming out with dry process products that have not been thoroughly vetted. And when they have problems with their pavement, they get blackballed, but rubber gets blackballed, not
Right,
just
that's what I'm getting at.
just the one contractor. So we work with the states to develop very exacting specifications. We encourage the states to demand a substantial body of field data instead of just having someone come up and say, I've got a great idea, let's go ahead and try this in a road. And to date, we have not had what I would call a failure in hundreds and hundreds and hundreds of projects because of our attention to quality. And that is the discipline that is required of the rubber recycling industry, the tire recycling industry, is to not get hooked into a situation where you're putting an inferior product. And inferior can not only be the technology that you're using with the rubber and the way that the rubber is being put into the plant, but also the cleanliness of the rubber, fiber and metal removal, water content of the rubber, chemistry of the rubber itself. All of those things matter.
And you have standardized testing for that?
We have standardized testing. There are a series for our products. There's a series of ASTM procedures that have been developed that can be achieved by a typical plant, but they have to meet those specs in order to be used in our process.
So are you seeing the engineers getting involved, the civil engineers? Is that who you would deal with directly on something like that?
Well, the paving engineers with the road owning authority, which can be the state,
have the
decision
decision
maker,
maker,
the city, right?
Yeah.
Those are the people that you work with to bring them along and get them to say yes.
And it takes a little bit of an open mind in that scenario. I mean, just like anything else, nobody likes change, right? And some of these guys are dead set against change. So having someone in a city, like for example, in Idaho, we have the Idaho Transportation Department, big group, right? Huge, probably doesn't move quite as nimble as some of the cities and counties. So I had a public works director from one of our local cities come to me and say, hey, I can help you fast track at least some test plots, right? Some test roads. So we're kind of starting from I've got somebody on board to now I got to figure out how to do it. So that's where I met you, and I talked to Doug Carlson, and getting different, feedback. I went to the Rocky Mountain Asphalt Producers Group meeting, and that was very educational. Kind of like drinking from a fire hydrant, though. There's a lot of information coming at me, much like the workshop yesterday, and one that I'm going to come see you speak. There'll be a lot of information that I'm having to learn, but knowing that there's data to support it. You had talked a little bit about the cost savings, thickness of the pour, things like that. Can you touch on that a little bit? Like
Sure.
What you're talking about when you get to those folks?
Just very quickly, we talk about a value proposition, meaning that what do the users get in the way of benefits? And there are a lot of different pieces to that, which we could spend probably half an hour talking about alone. But the key benefits are it's less expensive than other modified asphalt. For standard asphalt, it lasts longer, and in both cases, you get better stopping in wet weather, okay, and you get quieter ride. And finally, it's not in vogue yet, but it's a significantly smaller environmental footprint, and that is coming to the paving industry. It's being driven by the National Asphalt Pavement Association, but they are asking for more sustainable pavements, and the industry is going to be buying those products. So that value proposition drives, along with reliability, the value propositions drive those decision makers to yes. They're afraid of risk, but they also know that they can't pass up a great value proposition. Dry process rubber, our dry process rubber was built to satisfy those demands and give them a reason not only to try it, but to use it over and over again. And the good news is we've got hundreds of asphalt plants now that are using this regularly.
Helps. Right?
It is not new to the industry anymore.
Yeah, and that's the trust factor, right? And
Yes.
I think about that because you can supply all the data, you can put forth all the information, but you still got to look them in the eye and say, we're not going to screw this up. You can trust what we've done in these scenarios. You can trust us to take this forward because of what you mentioned earlier.
Yeah.
The complete replacement is quite a bit more expensive than just the little change to their process.
Hugely.
So the mistakes I'm sure they take very serious, and they've probably experienced them at some point in their career. So that trust factor, I think, Red, you bring that to the table, and I'll just commend you and tell you I appreciate you for all your work on that, and we're excited in Idaho to have something like that going. So I guess if anyone wants to reach out to you or your company, they just go right through Asphalt Plus.
Yeah, they can go to www.asphaltplus.com, and that's spelled out, not the plus sign.
Okay.
They'll find a wealth of information on our website, and we're a phone call away, and we are working all over the world to bring this technology to the marketplace, and the marketplace is adopting. So keep our fingers crossed. This will be another area where we can see a productive use for scrap tires.
Thanks for coming on. Everybody, this is exactly what we're here for, is we want to talk about these new, it's funny to call it new, but these technologies that are really getting traction, no pun intended. And we're excited that Red came on, and thanks for coming on, Red.
Pleasure. Good to talk to you.
You too.